Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank T.S. Shamsul Fakar bin Abdul Ghani and Puan Doliana binti Abdul Muttalib for being able to spend time here allowing me to present my project, which is the development of air monitoring system for kindergarten. Before we start, allow me to introduce myself. My name is MohamadAmirulBinAmjathJamal from Faculty of Electrical, Electronic and Engineering Technology. My supervisor is T.S. Wan Nur Hisham bin Abdul Rashid. First, I would like to show you the poster for my degree project. Air pollution is the biggest concern in any country, whether it has been developed or is growing, particularly in urban areas of developing countries where many gaseous pollutants are released due to industrialization and increasing number of vehicles. Although we are focusing on outdoor environments, indoor air quality is also important for our health. 90% of the day is spent indoors. To prevent health problems, a clean, safe, and comfortable air quality is important. A strong air quality index is also important for children and elderly people because they are believed to be more vulnerable to the pollutants inside a building. This project purpose is to design a low-cost air monitoring system that detects the air quality of the air inside an environment. It consists of several sensors that is used to detect temperature, humidity, and the substance in the air such as dust and carbon monoxide. The objective of my project is first to design a low-cost air monitoring system with the concept of Internet of Things (IoT). Next, to design a portable and lightweight air monitoring system for user convenience. The last one is to apply cloud computing in the system for convenient ways to store and view the data. Moving on to the research methodology. This is the model of my project. Basically, there are 4 sensors used alongside with a microcontroller. As we can see, the microcontroller that is used is the ESP32. Next, sharp optical dust sensor, which is to detect dust particles. The detected minimum particles is around 0.8 microns. DHT11, which is a simple digital temperature and humidity sensor. Next, we use MQ135, which can be used to measure NH3, benzene, or carbon dioxide gas. MQ7 is a sensor to detect carbon monoxide gas in the air. The concentration of carbon dioxide gas can be detected from 20 to 2000 ppm. Moving on to the software part. The first one is Arduino IDE. It is an open source software for writing and uploading a program into the ESP32 board. Next, MIT App Inventor. It is a platform to create a mobile application online. The application that is made for this project has been done using this MIT App Inventor. Lastly, ThinkSpeed is an Internet of Things platform which is enable users to gather and store clouds, sensor data, and establish the IoT applications. The IoT platform ThinkSpeed provides software for data collection and observation. Next, for the flowchart, as we can see from the flowchart in the poster, the ESP32 will establish connection from Wi-Fi module until it is connected. Then, if it's already connected, the sensor will then process. Then, the sensor collects real-time data. Moving on, it will check the connection with ThinkSpeed. Then, if it is not connected, it will then reset back the connection with the web server until it is connected. When connected to ThinkSpeed, it will then perform sensor data visualization and analysis and then display the analyzed data on ThinkSpeed. Finally, from the real-time data, it will be displayed to the mobile application that has been set for ThinkSpeed channel. Now, we are moving on to the result and analysis part. The first, as we can see, there are 4 graphs shown in the poster. The first graph is the temperature graph. The reading was between 27 to 30 degrees Celsius. The recorded temperature at 30 degrees Celsius on the first day was taken in the afternoon and the weather is considered hot. On the 5th of January, the temperature dropped by 2 degrees Celsius due to the cold rainy weather in the morning. The temperature is then stays at 29 degrees Celsius consistently for 3 days on normal weather. Moving on to the next graph, which is the humidity. Humidity is temperature dependent. The relative humidity increases when the water vapor content remains the same and the temperature decreases. The relative humidity decreases if the water vapor content remains the same and the temperature increases. It's because colder air doesn't need as much humidity as warmer air. On the first day, the humidity is at 71%. On the third day, the humidity increases by 4 because the reading was recorded in the morning and the weather was wet and raining slightly. Next, the graph shows the dust level collected each day. On the first day, there was little to no dust recorded. It was recorded in a living room that has been cleaned a day before. On the 5th of January, the dust level increases to 2 because the reading was recorded outside of the house. Thus, the dust level between the living room and outside of the house is different if we compare it logically. Finally, the carbon monoxide graph, obtained from MQ7 sensor. There are readings that will indicate whether the level of carbon monoxide gas is safe or harmful. For example, 50 ppm and below is considered a low level or safe. When the reading reaches between 51 ppm to 100 ppm, it is considered medium condition. If the level of carbon monoxide gas exceeds 100 ppm, then the air is considered harmful or not safe. From the graph, on the first day, the reading was at peak. It is because the reading was recorded in a living room which is near to a gas stove in the kitchen besides the living room. The reading stays consistent in other places such as outside of the house and in the bedroom. For the last part, this is an overview of ThinkSpeed and mobile application that has been created. The visual display of data on ThinkSpeed matches the measured air quality. It depends on the network traffic and internet connection speed. The rate of changes of the data on ThinkSpeed was dependent. You can access the air quality status at any time with automatic updated at designated times. Next, the mobile application is integrated with the project system. It will display the real-time data that is obtained from all the sensors. Below the interface, it will show an alarm on the status if the condition of the air is not safe. As a conclusion, the objective of this project is to design a low-cost, portable, and lightweight air monitoring system for user convenience is achieved. Hence, the first problem, which is the current air monitoring system, is high in cost, is solved. This project only consists of 4 sensors and a microcontroller. There is no heavy equipment used for this project. As a result, this project model can be carried easily and comfortably. Next, the project is linked with ThinkSpeed platform, which is to store the real-time data obtained from the sensor in the project. Also, a mobile application that is integrated with the project system has been successfully created so that the reading from the sensor can be monitored easily from the smartphone. Thus, cloud computing is applied in this air monitoring system project. That's all from me. Thank you. As we can see, this one is the ESP32 microcontroller. This one is the sharp optical dust sensor where we detect the particle from inside the hole. This one is the MQ135 sensor, MQ7 sensor, and lastly the DHT11 sensor. To know whether the system has successfully established a connection with the internet, we can observe it on the hotspot that we set up earlier. This is the hotspot that has been set up, which is the server X. As we can see here, there is one connection that has successfully connected to the server X hotspot, which is our system. Now we move forward to ThinkSpeed website. This is the channel ID. And below is the reading chart that has been measured by the sensor. As we can see, the temperature keeps changing from the chart. It is because of the real-time data that is analyzed and stored here in ThinkSpeed. The date and time of the data taken is also displayed in this chart. Same goes to the humidity. All the data taken is real-time. This chart will stop taking data once the system has been turned off. Lastly, I will show you how the mobile application works. As we can see on the screen now, this is the ThinkSpeed cloud server. So now we just open the application. So this is the application. So as we can see, the carbon monoxide reading, for example, is 28, humidity 53, and the temperature is 26 degrees Celsius. We can see from the graph, for the temperature, the latest one is 26, and the humidity graph is 53. This is the latest one, and the latest one will be changed. There will be some delay when the mobile application read the data from the cloud, from the TeamSpeak cloud.